Laplace transform. Laplace transform. Okay, the Laplace transform of an expression f of t is denoted by Laplace transform f of t and is defined as the semi-infinite integral. The parameter s is assumed to be positive and large enough to ensure that the integral converges. In more advanced application, s may be complex, and in such cases, the real part of s must be positive and large enough to ensure convergence. So when we talk about Laplace transform, what we are trying to say is that the Laplace transform of any function, Laplace transform is the Laplace transform of f of t is equal to integral of e raised to the power of minus st f of t dt. So this is how you denote a Laplace transform. Okay, your Laplace transform, this one now is still the same as you writing your f, capital letter F of what, of s. So now while you're trying to solve a Laplace transform, so the Laplace transform f of t, you consider this is a small letter f of t, is equals to the integral e raised to the power minus st f of t dt, and which is the same as what, capital letter F of s. So please take note of this because we are going to be using this very soon. So now now you need to understand something, that if for example you are to find the Laplace transform of a constant value, for example let's say f of t is equal to a, so where a is constant, so where a is constant, so if a is constant, so the Laplace transform of a will be equal to integral of e raised to the power of minus xt, then my f of t is what, is a, that's a constant, right? So multiply by a dt. So now you notice that this is an integration, right? So this a is a constant, so when you want to integrate anything, you take out the constant. So we are going to have a outside, then we have e raised to the power of minus st dt. So what do you do at this point? So what you are going to do here is that you integrate this. So how do you use integration by substitution? So if I'm to integrate this, I'm going to say let u be equal to, or let u be equal to, that is minus st, right? Then if that is the case, then I'm going to say that my du dt will be equal to what? Will be equal to minus s. So therefore my dt will be equal to what? Will be equal to, if you cross multiply, you're going to have minus du over what? Over s. So you can take it back to the original equation. So the Laplace transform of a will be equal to what? Will be equal to a integral, this infinity is 0, integral of what? Of e raised to the power of, you already said u is equals to minus st, right? So it's going to be e raised to the power of u, then multiply by your dt. Your dt now will now be what? Will now be minus du over what? Over s, isn't it? So now at this point, so what you are going to do is that you are going to take out the constant. You notice that this x is a constant, you're also taking out this minus, so it's going to be minus a over what? Over s, then integral of what? Of e raised to the power of u du. So now you have to integrate. So if you integrate this, so if you are integrating e raised to the power of u, it will still give you e raised to the power of u. Then you put your boundary, that's infinity to 0, then minus a over s, then into what is your u? Your u is what? Is minus st, then infinity and 0. So what you are simply going to do is that you are going to put in the boundaries. So, and what are you putting? You use it to replace t. So now what are you going to do? You're going to have e raised to the power of minus s into infinity, then minus e raised to the power of minus s into 0. Okay, so which is going to be what? Which is going to be minus a over s into, this will give you 0, then minus s times 0 is equal to 0, then e raised to the power of 0 is going to give you what? 1. So finally we are going to have minus a over s into what? Into minus 1, which is going to give you what? A over s. So now what we are trying to say is that when you find the Laplace transform of a tool, your answer is what? So the Laplace transform of a constant value is going to be what? Is a over what? Over s. Over s. So for example, let's say I'm to find the Laplace transform of 3. So I say f of t, if f of t is equal to 3, so then the Laplace transform of f of t will be equal to what? S. So if f of t is equal to 4, then the Laplace transform is going to be what? 4 over what? Over s. So that is that for constant values. So if you have to find the constant value of anything in Laplace transform, it's going to give you the constant over s. So let's look at another one. For example, let's say the f of t is equal to e raised to the power of minus at. Now find the Laplace transform. So you have to find the Laplace transform, the Laplace transform of f of t. So what are you going to do? So the Laplace transform of f of t will be equal to what? Will be equal to integral e raised to the power of minus st. So now what is my f of t? My f of t is now e raised to the power of minus at dt. Okay, so which is going to give me integral of, now this is e, so I'm going to use indices to bring it together. So I'm going to have a common base e, then go to minus s of t, then this is going to be plus, then plus multiplied by this minus is going to give you minus a t dt. Now which is going to be integral of, now e raised to the power of, now notice that minus is common, so we are going to have what? S minus is common, t is common, minus s plus a over what? And multiplied by t dt. Okay, so now let's move further. So now the next thing you do is that since you have your e raised to the power of minus x plus a dt, okay, so what are you going to have? So the next thing you do is that you say let u be equal to minus s plus a t, then you can say your du dt will be equal to what? Will be equal to minus x plus a. So then your dt will now be what? Will now be minus du over s plus a. So now when you take it back to that integral, when you take it back to the equation, you're going to have integral, sorry, this is infinity, then e raised to the power of, now you said this is u now, then multiply by, what's your dt? Your dt is minus du over s plus a. So now you take out the constant is minus 1 over s plus a. Okay, then integral of what? Of e raised to the power of u du. Okay, so which is going to be minus 1 over s plus a then into, if you integrate this, it's going to give you e raised to the power of u, then your infinity to 0. Okay, so which is going to give you, that's minus 1 over s plus a, then into e raised to the power, what's your u? Your u is minus s plus a t, then you put your boundary, that is infinity to 0. So which is going to be minus 1 over s plus a. So now you can put in your boundary, so it's going to be e raised to the power of minus into s plus a, then into infinity, then minus e raised to the power of minus s plus a into 0. So which is going to be minus 1 over s plus a, so into, this is going to give you 0, then minus, this is going to give you 1. Okay, so now when you multiply, you're going to have what? 1 over what? S plus a. Okay, so now what we're trying to say is that the Laplace transform of f of t, when f of t is equals to e raised to the power of minus at is equal to 1 over s plus a. Okay, if f of t is equal to e raised to the power of minus 3t, okay, then your Laplace transform, the Laplace transform of e raised to the power of minus 3t now, minus 3t will be equal to what? Will be equal to 1 over what? Over s plus 3. Now the Laplace transform of e raised to the power of 4t will give you what? 1 over s minus 4. So it's as simple as that. Okay, let's do another one. The Laplace transform of, for example, e raised to the power of, let's say, minus 60 now. The Laplace transform is going to give you what? 1 over s plus 6. So that is basically for Laplace transform. So let's just look into other function. For example, let's say you have to find the Laplace transform of t raised to the power of n. So this n means any positive integers, okay, from 1, 2, 3, 4 upwards. So if you have t raised to the power of n, so the Laplace transform of this is going to be n factorial over s raised to the power of n plus 1. So for example, let's say you have to find the Laplace transform of let's say t raised to the power of 2. So it's going to be what? It's going to be 2 factorial over s raised to the power of 2 plus 1. So which is going to be 2 factorial is 2, then over this is going to be s raised to the power of 3. So for example, let's see, you have to find the Laplace transform of t raised to the power of 4. T raised to the power of 4. T raised to the power of 4. So it's going to give you 4 factorial over s raised to the power of 4 plus 1. So which is going to be 4 factorial is 24 over s raised to the power of what? 5. Okay, so that is for that. Then let's go into another one again, another function. For example, the Laplace transform of sine 80, for example. So the Laplace transform of sine 80 is equal to a over s square plus a square. Okay, so let's take some example. Now what I'm trying to say is that if, for example, you have to find the Laplace transform of sine 3t, now you notice that here your a is equal to 3, isn't it? So what you need to do is just put in 3 into this formula. So sine 3, the Laplace transform of sine 3t is going to be 3 over s square plus what? 3 square. So which is going to be 3 over what? Over s square plus 9. So it's as simple as that. So let's take another example. Let's say you are to, so the Laplace transform of cos 80. So the Laplace transform of cos 80 is the same as s over x square plus a square. So for example now, so let's say the Laplace transform of cos 40. The Laplace transform of cos 40 will give you s over x square plus what? Plus 4 square. So which is equal to s over s square plus what? Plus 16. This is 16, sorry, 16. So then let's look at these two final functions before we, for example, let's look at this function again. The Laplace transform of sine, so let's say sine 80. So the Laplace transform of sine 80 is equal to a over s square minus a square. So that is it. So for example, let's say you have to find the Laplace transform of sine, let's say sine t, for example. The Laplace transform of sine 3t will give you 3 over x square minus what? Minus 3 square, which is 9. The final function, the Laplace transform of cos 80. The Laplace transform of cos 80 will give you, it's going to give you s over s square minus a square. So now let's take this example. Laplace transform of, let's say, cos 5t. You already know that your a is 5, right? So just put in 5 here. So it's going to be s over what? Over s square, then okay, so it's minus, so minus what? So minus 5 square. So which is going to be what? S over s square minus what? Minus 25. So this is how to find the Laplace transform of any function. So these are the basic functions. So in the next tutorial, we are going to go deep by looking at some theorems whereby we have combination of two functions. For example, let's say we have the function of t, we also have the function of sine. We are going to look at how to solve this thing. So thank you for watching.